Yeah, hi. This is my narrated video on forecasting and for Business 370, and you can see here we have some an overview which I let you read that. So I'm gonna switch to what is the purpose of forecasting. Forecasting is the process of predicting the future. It provides basis for planning, decision making over short-term, medium-term, and long-term horizons. So it's basically like if you have sales, say monthly sales, and you have data from last 3 years, and you want to make projections for sales volumes for the next 12 months so that you can plan for staffing, inventory, and so on. So we call a short-term forecast is for less than 3 months, medium is 3 to 2 years, and long-term is more than 2 years, roughly speaking. So considerations in selecting a forecasting approach. How are we going to do our forecasting? Things to keep up is the use and the decision characteristics, like overall significance, forecasting range, the volume, how many items we want to be forecasted. The example I gave you about sales is just one item, but you could be interested in forecasting multiple items, and other like benefits, risks, and so on. Resources available for the task, like computing power, software, people, data, etc. And existing level of sophistication, current users, current forecast system. If you have only Excel, you cannot do forecasting that requires more sophisticated techniques. Data patterns, that's an important part. We're going to spend a lot of time on data patterns. We're going to check when we collect past data, does it exhibit stationarity, trends, seasonality, cycles, noise, relevance of history, etc. So all these factors we need to pay attention to. And cost benefit analysis, how much going to cost us, what's the benefits. And there are two types of cost: the cost of doing the forecast and the cost of the inaccuracy of the forecast. We are not going to be able to have a forecast that's perfect, and that's fine. We tolerate some inaccuracy, but we have to be able to assess that inaccuracy. Okay? So this is a list of forecasting costs: implementation cost, maintenance cost, and so on. And the inaccuracy cost, it's associated because the forecast is off target. So how do we handle that? General steps to forecasting: when to determine the use of the forecast. Why are you doing it? Select the items to be forecast. Select the forecasting models. Gather the data. When I gather data for the forecast, I'm going to make the forecast. I'm going to validate. We make sure our forecast provides reasonable accuracy, and implement the results. Then talk about realities about forecasting. Basically, forecasts are seldom perfect, and we know that. And most techniques assumed an underlying stability of the system, which means, like, since we are forecasting into the future, our data is from past. We assume that the future, the period we are forecasting, is going to behave in some way similar to the past, and that's reasonable unless there are some intervening big events. So when we collect data, so first we have to look at our data. Say I have sales for my last 36 months or 3 years, but monthly sales. First thing I want to look at is the long-term trend. So here we basically we check for upward or downward trend. If there is no trend, which means my model is stationary, which means my data doesn't go up or down primarily. If there's a trend, that means I can model that as a linear or quadratic or exponential. Everybody should be familiar with a linear trend because that's what you do in linear regression analysis. Okay, so here's an example of a downward linear trend. So if my data points were close to this line going downward, so that indicates I have a downward linear trend, while an example going upward would be an upward trend. And if my data points were to go up and down like this, that would which means more they go around more a horizontal line, that indicates there's no trend, right? And that indicates stationary model. Another thing we want to check for is seasonal variations. Since we're looking at time series, increases or decreases due to certain time intervals or climate changes. Like season can be winter, can be day of the week, month of the year, etc. So here are examples of seasonality where in my monthly data I could have 12 seasons in a year. So my sales probably depends on the item I'm forecasting, could go up during summer times and go down during winter times. So there will be some seasonality there. So if I have my period a year, I could have 4 seasons, the quarters, or I could have 12 seasons representing months, or I could have 52 seasons representing weeks. If my period is the month, I could have 4 seasons representing weeks. If I have weeks, I can have days in a week to represent the seasons, okay? Or 5 days in a week if I don't count weekends. So that's seasonal. Cyclical variations. There are also data can exhibit some cyclical variations, but these are temporary upturn or downturn that don't seem to follow any pattern, seasonal or trend. Usually they result from economic conditions. For example, demand for cars is linked to overall economic conditions. So these are usually multi-year business cycles. They are very hard to detect in data, especially if you don't have data over an extremely long period of time. So we will not discuss business cycles in this topic. There's also the random effects, and these are changes in the time series due to unexplained factors, i.e. factors that cannot be accounted for in the model. And these random effects are the primary reason our forecast is not perfect. And so we have to pay attention to random effects. Okay? Next, we're going to look at steps in the time series forecasting process. So suppose I have the data now, and so what are the steps that are needed? First, I want to hypothesize a form for the time series model. Can do that by collecting historic data and graphing it. Graphing data is very important. A picture is worth 1,000 words. We can see from the graph whether our data has a trend, whether it's stationary, or whether it has seasonality. So these are the 3 things we pay attention to: stationarity, trend, and seasonality. So testing is also needed in some cases, and we're going to look at some tests for stationarity and trend. Then we select a forecasting technique and determine its parameters. Again, the forecasting technique will depend on what we find out in in graphing our data and the patterns we see there. And then once we pick the technique to use, we prepare a forecast using the technique we picked in step 2. So let's focus on selecting a forecasting model. How do we check assumptions? So we have the data now, we graph the data, and we find out what possibly can we find out. We plot the data, basically graphing it using any software package, and we can have, if our data looks horizontal, means no trend, or we have stationarity. We can have, if we have an upward, can have an upward trend or downward trend. We can have seasonality. We have to identify the seasons in the period and the period in this case. And we can have both trend and seasonality together. And we can have cyclical behavior, which we are not going to cover here. So a stationarity model is a stationary model appropriate for our data? First, we're going to test that, and we know how to test that, testing for stationarity or a trend, basically. This is done by using simple regression analysis, which you should have done a couple of times by now in a couple of courses in business class and in the math probability class. So the linear model is this, where this is your dependent variable. That's your independent variable is t now, and these are your parameters. That's the y-intercept, and that's the slope, and that's your unexplained factor. That's your error term. So then now to test for linearity, we do this test. We test whether the slope is 0, which means if we have a 0 slope, that means there is no linear trend. Our data is horizontal. If the slope is not equal to 0, then that indicates a linear trend. Of course, if it's positive, indicates upward trend. If it's negative, it would indicate a downward trend. Now we run this model using the simple regression analysis on our data, and if we get a p-value which is less than 5%, that indicates a linear trend. Otherwise, we don't have a linear trend. So if our p-value is more than 5%, that means we have stationary data, and now we have to pick a stationary time series model for our analysis. If we have a trend, then we can use a regression model to do the forecasting. And so now we are only looking at these two cases, trend and no trend. We are not looking at seasonality. Okay. So how do we check for seasonality? This is best achieved by graphing the data. There are other more sophisticated computing techniques to check for seasonality, but they are beyond this class. Basically, they involve computing autocorrelations of several lags. Lag is a period. Okay. Also, how do we check for cyclical components? Again, this is best achieved by graphing the data and looking for these patterns over long periods of time. Again, we are not going to pay attention to this. Okay, now we talk about the forecast error. So I'm going to let my error term equal, this is my yt. So we're looking at the error term et equal yt minus ft. So now we are going to look at the forecast error, and basically suppose my yt is my sales, previous sales for my last 36 months. My ft is the forecasted values, and this could be from month 1 to 36, or starts at month 2 or 3 or 4, depends on the forecasting technique. So yt is the actual, the observed value, and ft is the forecasted value, and so ET is the error. It's the forecasting error of the time series. Now we can calculate there are several ways of calculating these error terms, and we're going to look at some of these measures. We're going to let y bar be the average of all y's. Means add all y values, divide by their total. Okay. So now suppose we have n periods. The first method of calculating the error is called mean forecast error, MFE, and basically you add all the errors and you divide by their total. So it's the average of all errors. And this is the AT YT minus FT over N. The second one is sometimes it's more reasonable to look at the percent errors. So you take ET divided by the magnitude of the observed value. So that's the times 100. So that's called MPE, mean percent error. So you take the error, divide by YT, divide by 100, add them up all, and then average them out, divide by N. Here is one of the popular forecasting errors. It's called MAD, mean absolute deviation. And basically you average the absolute values of the errors. So you take the errors can be positive or negative depending on whether the forecasted value is less than the observed value or larger than the observed value. So if we just add the absolute values, neglect the negative signs, that gives me the sum of all absolute errors, so they don't cancel each other out, and divide by N. This is a very good measure for forecasting errors, except that sometimes it's not so easy to work with absolute values. And so one way to get rid of the negative signs of error so they don't cancel out is to look at the error term and square that. So we square the errors, we add them up, and we take the average, and that's called mean squared error, MSE. But now when you square the errors, they're going to get much larger, and so we take the square root of that at the end, and we call that the root mean square error, RMSE. Oh, this would be RMSE here, the root mean square error. And another error is the mean absolute percent error. So the same way as we get the MPE, we get the MAPE, which is the error divided by the observed value, the error in absolute value, times 100. We add those up and we average them, and we call that the MAPE. So these are the most popular among this list is the MAD, MSE, the RMSE, there should be R here, MSE, and the MAPE, MAPE. It's also the largest absolute deviation. Sometimes you want to minimize the maximum deviation, and that's basically take the maximum of all the errors. And also, if you're using a regression model for forecasting, like when you have a trend only, we calculate R square, which is called the index of determination, and this should be familiar from your regression course. So R square equal SSR over SST, where the SSR is the FT, the error due to regression, FT minus Y bar square, add them up, and the SST is YT minus Y bar square, and add them up. And we know this relationship that SST equal SSR plus SSE, which is the square of the deviation. So YT minus FT is called the deviation, that's the square of the deviation, and that's the sum of square of deviations. Okay. Here are some comments on these errors. So MSE and RMSE, the mean square error and the root mean square error, give greater weight to larger deviations. because the larger the deviation, when you square it, you give it more weight. So this is appropriate when the modeler, when we look at problems where we wish to give larger forecast errors proportionately more weight than small errors. MAPE considers the forecast errors relative to the corresponding observed values or the corresponding time series values, and this helps with the scale issue. And general rules for error is that we want these errors to be closer to zero as best as possible. They'll never be zeros most of the time. They will be large, so the smaller the error or the closer the error to zero, the better. Some of these errors can be negative, like the first two. So the mean MFE and MPE can be negative, so they are directional based. Also tells you whether you are overestimating or underestimating, which what we're going to talk about here. So forecast errors direction based, which means the error can be positive or negative. If you take these are cumulative forecast error, add all the errors. If you divide by n, that's the average, called mean forecast error. And the MPE, also the percent errors, they can be both positive or negative. So it gives you an idea about the direction of the forecast, whether your method is over forecasting or under forecasting. Okay, so this is how we compute, get the forecast error. So the next video we're going to talk about techniques for forecasting, and want to start with stationary models. Thank you.